Hi, welcome to this. It's about isotopes and some of the practical applications of these isotopes. So most elements have 2 or more isotopes. What are isotopes? Just for those of you who forgot, isotopes are atoms with different numbers of atoms of the same element with different numbers of neutrons. Okay? Nuclear changes in an atom occur only in the nucleus, guys. This should hopefully help you out there. That's how I would actually approach that one, okay? The nucleus of an atom consists of protons and neutrons. In an isotope, the number of what varies? Well, if it was a number of protons, it wouldn't be the same atom. Electrons, or when the electrons vary, that's ions, quarks, no. So the correct answer is neutron. And in isotope, the number of neutrons vary. Which of the following subatomic particles, also known as the fingerprint of the atom? Well, it's the protons. Why? Protons are the fingerprint of the atom because you can identify the atom by the number of protons it has. Different isotopes of a particular element contain the same number of protons, guys. It's this particular element. They're always, if it's the same element, it's always going to have the same number of protons. Okay? The difference between carbon-12 and carbon-14 is the number of, well, what would cause a mass difference between 2 atoms of the same element? Well, it can't be the same number. It can't be the number of protons because they're the same atoms. So they have to have the same number of protons. So it has to be neutrons, okay? Because electrons really have nothing to do with mass. Carbon-12 and carbon-14 they can't have different number of protons because they're the same element. They do have the same number of protons, that's true. Do they have different number of electrons? No. If they're neutral, no. And they don't have the same number of neutrons, and you know that because the mass number is different. This is the, just in case, mass number that 12 is. So they have the same number of protons. Carbon-12 and carbon-14 have the same number of protons. Why? Because they're carbon, and carbon always has the same number of protons. One atom of carbon has the same number of protons as another atom. A student is reading about uranium isotopes. It doesn't understand how they can be the same element. Your best answer is isotopes are not the same, but in the same family as the main element. Really? No. Uranium is unique and does not follow the definition of isotope. No, isotope is a standard definition. So far A and B are wrong. Isotopes all have the same number of proteins. So yeah, there you go. It's like they're brothers or twins because they're the same DNA, but maybe the haircut's different. Guess could be one way to look at it. So isotopes all have the same number of protons, which makes them the same element. There you go. Okay? The electrons do not change in isotopes, even though, yeah, they do. Okay? Okay. Atoms of a certain isotope have 73 neutrons and a mass number of 123. What is its atomic number? Well, mass number equals protons plus neutrons. Okay, so this time we have mass number is 123, and we know that protons is equal to the atomic number, just in case. Protons plus 73. Well, I need to subtract 73 from both sides. Why? So I can isolate for P. 0, 7 minus 12. Last time I checked was, 50. So what's the atomic number? 50. There you go. If an isotope has 7 protons and a mass number of 15, how many neutrons does it have? Again, mass number equals P protons plus neutrons. Okay, so it has 15 equals 7 plus N, number of neutrons. Subtract 7 from both sides. So the correct answer is 15 minus 7 is 8. The atomic number of an isotope is 17. If it has a mass number of 35, then how many neutrons does it have? So we know that mass number equals protons plus neutrons. So we have a mass number 35 equals 17 plus neutrons. So now we need to solve for n. Subtract 17 from both sides. Okay, it's 18, guys. And double check your work by adding them back up, and that totals back up to 35. Okay, and again, if it's telling me the atomic number, remember the atomic number equals the number of protons equals. Just reminding you and reinforcing that because it's pretty dang important. Okay, which of the following are isotopes of each other? An atom with 17 protons and 18 neutrons. Okay, so let's just start there. Is that going to be an isotope of an atom with an atomic number of 16 and an atomic mass of 32? Remember, atomic mass is not equal to the mass number. Atomic mass is about abundance and relative abundance of the isotopes. So you cannot use this one as a choice. So anyone with 2 in the answer is going to be wrong because you can't use atomic mass. Okay? So that would make anyone also with 3 in the answer wrong, because an atom with an atomic number 16, because this one says 16, and this one says 17, and this one says 17 for protons. So that one's wrong too. So let's verify that 1 and 4 is the correct answer. An atom with 17 protons and 18 neutrons. An atom with 17 protons and 20 neutrons. That's the correct answer. And again, the reason that 2 is discarded, which results in you discarding 3, is because atomic mass relates to the relative abundance of isotopes. It is not the same as the number of protons plus neutrons. And it took me a couple seconds because it's kind of late tonight to remember to figure out exactly where they were going with this question, because it's kind of a weird question, but it's a really good one. So again, atomic mass is about the abundance of the isotopes. It's an average based on the relative abundance. It is not a direct protons plus neutrons calculation the way mass number is. One practical application of radioactivity includes treating and diagnosing medical conditions. There you go. Which of the following is a practical application of radioactivity? Generating energy? No. Yes, that's it. Measuring rainfall? No. Recycling plastic? No. Recording traffic? No. Natural radioactivity occurs because atoms have unstable nuclei. They don't gain protons, guys. Okay. Might lose them. Cobalt-60 is an isotope, and what is it used for? Well, it's used to irradiate food. It's kind of cool. Heavy water is used as a coolant in power reactors. Which of the following is an isotope of heavy water? What you need to know, well, what's water? H2O. So we're looking for something with hydrogen in our choices here. What's the only one with hydrogen? D. And that is heavy water. It's hydrogen with a mass number of 2. Modern medicines employ a device such as a positron emission tomography, PET, that can detect even the smallest tumors. Which of the following isotopes is used in a PET scan? Well, hopefully they don't ask you this because, wow, that's a hard question. And it's rubidium-82. Okay, and hydrogen-3. Okay, we already know cobalt wasn't there. Which method would be the most practical for shipping highly sensitive materials around the world? Well, practical way would be to have radioactive isotopic tracers. Why? Because we can track them without man. Just a matter of tracking them. And they're pretty easy to track because they leave a trail. Okay? Which of the following methods measures carbon-14 to accurately determine the age of an ancient artifact? What do you guys? Okay. It's not going to be X-ray crystallography. That's actually one of my friends does research there, and it's pretty interesting. It's not going to be radiowave analysis. It's not going to be sonar because that's about sound. It's going to be accelerator mass spectrometry. One characteristic of technetium, an isotope of an element, technetium-99. Blah, blah, blah. Only process. Uranium is used in nuclear reactors in the United States because uranium contains several isotopes and only one of them is fissile, which means only one of them we can split to get the energy we need. Okay? Now that supermicrobes are so prevalent, what is the most effective way to sterilize? Well, not with soap and water, not using antibacterial, it's to irradiate with cobalt-60. It actually helps kill the little boogies. Okay? In medicine, why is it so important to be able to use a radioisotope which is short-lived? Because we want them out of the body faster, guys. We don't want to kill the person. Because you got to realize, when you're treating somebody for cancer, you're actually killing cells. So you only want it long enough to kill the ones that are growing too fast, but not kill the person. What arguments support feared irradiation by gamma rays? Well, if we kill harmful bacteria, then we are preventing deaths from food poisoning. That's a good reason to use it. So if we kill the Escherichia coli before you eat it, then the chances are you won't get really, really sick. One societal implication of using radioisotopes in many everyday applications is disposal of associated waste. So implication, they're talking about, hey, what's a problem with doing this? And it is getting rid of the waste. The mass number of an isotope represents, well, what does it represent? We've talked about it. And what is it? It's the number of protons plus neutrons, because those are where we find the weight in there of an atom. It's in the nucleus. It's a dense core when compared with the electrons. Okay. The mass number of an isotope is also known as its a number. Okay. The mass number. So if it's carbon 14, this is be the A number. Whoever came up with that, I don't know, but it's also those things. Examine the figure below. The bottom number represents the number of protons. Okay, this is the symbol, and this is the mass. And you know that mass should be bigger than the number of protons. That's how you can help yourself figure it out. Okay. Examine the figure below. The top number represents What? Number 29. Nucleons. Nucleons mean the things in the nucleus. The particles. I should have used the correct word. But the nucleons represent the things, the particles in the nucleus. Okay. Examine the figure below. Which of the following is correct? Lithium has 4 protons? No, it doesn't, because we know right here that it has 3 protons, so that's wrong. So then this one might be right, B might be right, and D might be right, but C is definitely wrong because it says 7 protons. So now, if we know that this is the mass number, and mass number equals protons plus neutrons, then what do we know? We know that it can't be B because that's saying 7 neutrons. So it has to be 3 protons, 4 neutrons, because 3 plus 4 is 7. There you go. Correct answer. Examine the figure below. Which of the following is correct? Lithium has, what does it have, guys? Does it have 3 neutrons? Nope. 4 protons? Nope. 4 electrons? No. So the only possible correct answer is 7 nucleons, which remember we said nucleons were the particles inside the nucleus. Okay? Examine the figure below. Which of the following is correct? Lithium has A, 7 protons. No, because it has 3. That's the atomic number, and that tells us that. 4 neutrons and 3 protons. That is correct because 7 minus 3 is 4. And what is the mass number? Mass number is the number of protons plus the number of neutrons. Doesn't have 3 neutrons and 3 electrons, 7 protons. Nope. Correct answer is lithium has 4 neutrons and 3 protons. Okay, guys, I hope this short tutorial helped you out. I hope you're feeling much smarter. I know my son is. He looks like his head's going to explode. And get studying.